Hello, class. Welcome to our Chapter 8 opener. Mainly what I'm looking at is just some order of operation pieces and some things dealing with shapes. Chapter 8 is going to talk a lot about area, perimeter, circumference, things of that nature to help us get ready for surface area and volume coming up. But today we're just going to focus in on some simplifying pieces and how to find some answers to some expressions. So the first thing that we want to talk about is just looking at what's known as a composite figure. A composite figure is when there's more than one shape involved for the object. So this one on the left is really a trapezoid if you get rid of this middle line here. But this type of trapezoid is made by a rectangle and a small triangle on the right side. And so when you're looking for the shapes, the goal of these shapes is eventually we're going to be finding the areas of these shapes or the perimeter of the object. And so like this is a half circle or a semicircle. You got what looks to be a square. We're not sure. We need some numbers there or some tick marks to show that they're congruent. And then we have a triangle. So what you want to look at on these situations is how to recognize what those shapes are, especially if these lines aren't as obviously drawn, and you may have to draw those lines in yourself. For this question, if we just go through this first one has two trapezoids that make up a hexagon. Okay, that's a regular hexagon because all the side lengths and angles are the same around the edge. The donut idea will show up with circles. So you have a bigger circle and a smaller circle. So it might be find the area of this blue piece. That could be something that you see. Number 3 is kind of a strange question because it looks like it's just a triangle with a line on it. So it would be just two pieces of that triangle. If you kind of look from a distance, this might be going in one direction and might be going slightly different. So you just got to pay attention to that. But you got a trapezoid and a triangle here. You got two triangles that make up a larger triangle. The idea of the arrow, if you connect this line right here from the top to the bottom, you got a rectangle and a triangle. And the double arrow would have two of those triangles and one rectangle. Most shapes are composite figures if you really think about it. So if you take some objects, now they may have rounded edges. For example, like a desk has rounded edges. But they start out as the rectangle, or if you have a specific type of countertop and things of that nature. We just want to be able to see the shapes. And so if you have a hard time seeing that, my suggestion is that you add some dotted lines in, like on 5 and 6, so that you can see it a little bit easier. Okay, what we're going to look at now is a lot of evaluation of expressions, specifically dealing with exponents. So remember, 3 to the second power, or 3 squared, is 3 times itself, so 3 times 3 equals 9. What I want everyone to kind of do here is to write a little bit of work in order to solve this expression and evaluate. So I don't just want to see 3 squared equals 9, okay, on a question like this. Let's write it out. So 3 squared equals 3 times 3, and then that equals 9. 5 to the third is 5 cubed. Okay, 5 cubed is 5 times 5 times 5, and then that equals 125. Again, let's try to write this idea out, especially if there's not a whole lot else going on. We'll look at some more complicated questions, and maybe we don't have to write it out as much in those. But on these first ones, let's make sure we're writing those pieces out to remind ourselves what it means to be 3 to the second or 5 to the third. So here's what I mean by some more complicated questions. If we have some order of operations involved, when you evaluate, what we don't want is for you to just write 16. That's not very helpful for us. That doesn't show that you understand the order of operations. So you need to make sure you're showing some steps. And more steps here is probably better. So in this case, 4 times exponents come before multiplication. So 2 to the second power is 4. So notice, I figured out 2 to the second first, and then 4 times 4 is 16. It's just a constant flow. Now you can write that horizontally if you want. I tend to write vertically, so it's a little bit easier for me to read and see the steps. But either option is okay. For the next one, the most common mistake is students try to take 8 minus 2 first, which in the order of operations is very last. Add and subtract is all the way at the bottom. So you got to do exponents first. So 3 to the second is 9. And then I need to take 2 times 9, which is 18. Then 8 minus the 18. Remember, 8 minus 18 is similar to 18 minus 8, except it's flipped around. So 18 minus 8 is 10, but it's negative because the larger number was the subtraction or the negative. You need to make sure that you show these steps as you're going through the situation. What we don't want to see is just this original problem and the answer. That doesn't really help us. Okay, technology and things can find those things. We're trying to look to make sure we understand the order of operations as we're going through these questions. So you want to make sure that you explain that a little bit more on these scenarios. The next one, 17 to the second power, 17 times 17, which is 289. Notice, since this is the only thing happening in this question, I'm just going to multiply that out and show that, and then 289. I like this next question, negative 7 to the third. I'm just going to rewrite it. Negative 7 times itself, and then I just go left to right. Negative 7 times negative 7 is 49. Then 49 times negative 7 is negative 343. Okay, that's what we mean by showing our steps in terms of evaluating the expression. Make sure that you're looking at that perspective and make sure you're showing your work on these scenarios. The next one, I should do 3 squared first because exponents is first in the order of operations compared to multiply and addition. That's 9. 9 times the 5 is 45, and then the plus the 2, and that's 47. One mistake that I noticed that when people are kind of showing their work on this is they'll put 3 squared equals 9, and then 9 and then equals 9 times 5, which equals 45, equals, and you just have this rolling kind of your thought process, but you have these equal signs in between. When we're evaluating expressions similar to solving equations, everything needs to be there the whole time. So notice here, I know I didn't multiply anything by 5 yet, but I'm still writing the 5. I didn't ignore this plus 2. I keep writing it until I use it. You have to keep everything with you the whole time. It's like a box of stuff. You just keep putting pieces together like a Lego set. Okay, and eventually it becomes one answer. But you got to keep the box together until the piece is needed. So you want to make sure that you're working on that. For example, on this next one, I'm going to do 6 to the second, which is 36. But notice I write the 19, I write the minus 4. That's how your question should be written, and that's how your steps should be written. 4 times the 36 is 144. When you're looking at this scenario, one thing that you want to think about is this is a good opportunity to show what helps me as the teacher see if your steps are messed up. So, for example, on this one, 19 minus the 144, if you get 125, I can pinpoint and say, oh, by the way, that should be a negative 125, and we can explain it very quickly and say, oh, it's 19 minus 144 instead of 144 minus 19. So showing my steps there, even if I've made a mistake like what was just right there on the screen, okay, we can pinpoint and figure out exactly where the mistake was made. And you say, oh, you forgot this negative sign because it should be the larger number is being subtracted. So it should be a negative 125 as opposed to a positive 125. So that's something to keep in mind also as you're showing your steps. Okay, here's some more complicated versions following the order of operations. So for the first step here, in parentheses is 1 plus 8, so I find that to be 9. Okay, I rewrite everything else with it. 9 to the second power is 81. Rewrite everything else with it. 3 times 81, 243. Write the minus 4, keep it going. Then subtract the 4 and get the final answer. You need to make sure you're showing your steps. Show your work in order to find that answer in that scenario. The next one has an interesting piece kind of in the middle that we can talk about. So 3 plus 7 is 10. 10 to the second is 100. Notice I just kept writing everything else with it. From here, I can do both multiplications at the same time. So 2 times 100 is 200. 3 times the 4 is 12, and it's a subtraction in the middle. The reason I can do that is because they're separated by subtraction. And we already know that subtraction is last in the order of operations with addition. And so I can do everything else separate and then bring them together at the end, and I get 188. Some complicated pieces here with the brackets here. Brackets are just another form of parentheses that visually show like the difference. Sometimes on a calculator, when you put parentheses, you lose track of them. So sometimes when we write things by hand, we use brackets, or even on computer, we can use a bracket to help show that. Really, this is a parentheses. So this bracket here, we got to do everything in here first before we add to 20. But then inside that bracket, I still have to follow the order of operations. So inside the parentheses, 3 to the second is 9. 6 minus the 9 is negative 3. Then I need to take 2 times the negative 3, and that's negative 6, or subtracting 6. But notice, everything else just follows along. Your work should look like this. We don't want to see like one step and then you add the number, because then you'll get something that says like 8 equals negative 3, and that doesn't make any sense. Each step needs to include all the previous information every time. The 4 minus the 6 becomes a negative 2, and 20 plus a negative 2 should be 18. The next one has, the exponent has a bunch of order of operations pieces to it. So we got to do everything in the exponent first. So 2 times 4 is 8. And then I just go left to right. 10 minus 8 is 2. Then plus the 3 is 5. I'm going left to right in finding that. Notice I'm rewriting all the other pieces with it. I need to find 5 to the 5th power. Most common mistake is someone takes 5 times 5. But remember, 5 to the 5th is 5 times itself. Okay, 5 times. And that should be 3,125. And then subtract the 1 and you get 3,124. Remember, order of operations, do everything in that exponent first and then deal with the power, okay, at that point. You still have to think of that as in parentheses, even though it's not written that way. Similar idea to if you had a fraction with a complex piece on the bottom, you would still find that piece first. The other piece that I want to look at is just reviewing some things about solving equations. The first one is the base case, okay, just a two-step. To get rid of plus 5, I do minus 5 on both sides. Remember that not all your answers are going to be nice numbers. Some of you are still trying to do guess and check to find these answers, and I cannot stress enough how important it is to make sure you know how to work backwards in solving these questions. Okay, so for this scenario, divide by 3. 8 over 3 is really the answer. We could write that as 2 2/3 or 2.6 repeating, but really this 8 over 3 isn't that bad of an answer. When you move further in your classes, leaving things as improper fractions actually won't be that big of a deal. This next question I would distribute, so 5 times 2x is 10x. 5 times the minus 3 is minus 15. From there, it's a two-step equation, so add 15 to both sides, and then 10x equals 39, divide by 10, you get 3.9. I want you to be honest with yourself as you look at these two questions and say, do I show my work like this? Some of you have gotten the ideas figured out and you're good at showing your work in terms of a two-step equation approach, but others of you are still struggling with that. You want to make sure that you keep working on that because it's going to really help you long term to be able to show that work efficiently and quickly. The next question is something that we haven't talked about. I just want to introduce it. It says x squared minus 18 equals 7. Well, think of it the same way as just x. Okay, so we have to get rid of minus 18 first, so that would be plus 18 to both sides. Mathematics on solving equations is always about doing its kind of opposite or inverse operation. Okay, so the opposite or inverse of squaring is square rooting. So I'm going to take the square root of both sides to get rid of the square, and that just leaves me the x. Here's an interesting piece, and you'll talk more about this later. Again, we're just introducing it. The square root of 25 is 5 because 5 times 5 is 25. But what you'll notice here is that I said the answer was 5 or negative 5, and here's the reasoning. Let's go back to the original question. If I plug in 5, 5 squared is 25, minus 18 is 7. Agreed. But if I plug in negative 5 squared is negative 5 times negative 5, which is also 25, minus 18, which is 7. So there's actually two answers here, which kind of gets a little confusing. The other thing that I want to show is this notation. Instead of writing 5 comma negative 5, I could write it as this plus minus 5, which essentially says I want the positive or the negative 5 as my final answer. This last question here is distributing a negative 4 first, so I'm going to take negative 4 times 5x, which is negative 20x, negative 4 times a positive 1, which is a minus 4. From there, it's a two-step equation. Add 4 to both sides. I get 17. Remember, this is a coefficient of negative 20, so I have to divide by negative 20 in order to find that answer, and that would be negative 17 over 20. The negative sign could be in the numerator, out front, or denominator. What you can't have is both of them. If they're both are negative, the numerator and denominator, that would be negative divided by negative, which is positive. You could write that as a fraction. You could write it as a decimal. It depends on the scenario that you're looking at. Also, don't forget that you could write away divide by negative 4 here to get rid of the negative 4. I don't suggest that in this question because this isn't a number that's divisible by 4. If this was a 12 instead of 13, I might suggest just dividing by negative 4 first in order to find that answer. Okay, your homework today is a worksheet that deals with some of these topics and just simplifying and solving. Make sure that when you're looking at those scenarios that you're showing your setups and showing your work on those questions, and make sure you're systematically showing every step. That's what your teacher's going to be looking at. Have a good day, everyone.